Hello everyone, my name is Sakshi Garg and I'm currently pursuing my Masters in Computer Science from University of Florida. Today I would like to present my project on face recognition using Eigenfaces approach. First, let's discuss the need of face recognition system. Well, there are a lot of application of face recognition system, the most important being its use in security system nowadays. As we know, there has been a significant increase in electronic transaction, so there is greater demand for fast and accurate user identification authentication. Using the proper PIN gains access, but the user of the PIN is yet not verified. For example, what if somebody's ATM card is stolen and an unauthorized user somehow comes up with the correct personal code? Then what is the proof of authenticity? So here, face recognition plays a significant role. Face recognition technology may solve this problem since a face is undeniably connected to its owner. It is one of the many biometrics technology that we use. Now, let's see why face recognition is preferred over other biometrics. Well, there are a lot of reasons, and few of them are as follows. It requires no physical interaction on behalf of the user. It is accurate and allows for higher enrollment and verification rates. It does not require an expert to interpret the comparison result. It can use the existing hardware infrastructure, camera, and image already captured without causing any problem to the device. The most important reason is that it is the only biometric that allows passive identification in any environment. For example, identifying a terrorist in a busy airport terminal. Now, I would like to tell what is face recognition system. Face recognition system is a biometric method of identifying an individual by comparing live captured or digital image data with the stored record for that person. Sometimes the concept of face recognition is misunderstood with face detection. Well, both of these concepts are different. Face detection just detects whether there exists a face in the image or not. It just verifies if there is a face or a not face image. Whereas face recognition is slightly advanced. It identifies the individual whose image matches the image from the database. Well, there are many types of face recognition techniques based on how features are determined. First is based on local regions. Under this, there are two of them: local feature analysis and Gabor wavelet. Both of them basically recognize based on local features such as eyes, ear, or nose, etc. The second one is based on global appearance. It consists of two techniques: principal component analysis and independent component analysis. For this project, I adopt Eigenface method. The basic idea behind using Eigenface method is that it uses eigenfaces instead of original images for comparison. Well, eigenfaces are the eigenvectors of covariance matrix of the data set. Eigenfaces are also referred to as ghostly images. The prime reason of this eigenface approach is that it represents the input data more efficiently. That is, each individual face is represented in terms of linear combination of eigenfaces. To represent this data efficiently, we need a dimension reduction technique which can extract the desired number of principal component from multidimensional data. So here is when principal component analysis plays a role to reduce dimension. Now let me elaborate on principal component analysis. Principal component analysis is used to remove information which is not useful. Therefore, it reduces the dimensions of the data and accurately decomposes the face structure into the orthogonal principal components, which are also known as eigenfaces. Let me explain you this using this graph. Say there are two images represented by x-axis and y-axis, and suppose there is this third axis, namely k. So it can be easily observed that the two images can be better represented using this single dimension axis, that is k, instead of two dimensions, x-axis and y-axis. It basically represents the input data more efficiently. Moreover, PCA gives a suitable representation to phase space which otherwise forms a cluster. Moving on to face recognition process, it can be described as shown in this flowchart. Firstly, the images in the database are read. Then the mean for those images are computed. Also, the deviation of the images in the database with the mean image is found, and then the centered image is evaluated. Then then the eigenvectors of the covariance matrix, that is the eigenfaces, are found. The resulting image here looks like of a ghost. So these were the three steps which were a part of initializing the face recognition system. After this, we proceed to second phase, in which we recognize the unknown face image. So in this phase, first a test image is fed into the program. Then its eigenface components are computed by by the by the process as described in phase 1. Then the Euclidean distance between these components and the ones already found are computed. Now I would elaborate the whole process going step by step. Well, the first step is very trivial to obtain data from to form a data set, and it will be considered for the face recognition process. So this is the data set. Now the second step is to find the mean image of the data set. So the mean image is calculated using this formula, and the mean image would look like this. And the third step is to find the deviation between the input image and the mean image, which is computed using this formula. Then the centered image matrix is found based on this difference. Moving on to step 4, we compute eigenfaces. In this, covariance matrix is found using the centered image, which was computed in the previous step by using this formula. The eigenvalues are then found for this covariance matrix, and hence eigenvectors are computed. And the eigenvectors that are less than a specific threshold value are eliminated by principal component analysis, which we know is used for dimension reduction. Now continuing with step 4, when the eigenvectors are projected on a phase space, a set of ghostly images, that is eigenfaces, are formed. So these eigenfaces looks like these, and they seem to be ghostly. Now let's recognize an image. Let's see an example. Suppose we want to recognize an image. So this image is first fed into the program and then as the steps described in phase 1, the eigen components of the image are obtained. Then lastly, we compute the Euclidean distance. The Euclidean distance between the eigenface of the test image and the previous computed eigenfaces are evaluated. Then the minimum Euclidean distance among all is found. If it is greater than some threshold value, then we declare the image not found in the database. And if the distance is less than the threshold value, then the matching image with the minimum Euclidean distance from the database is displayed. So suppose this was my image that need to be tested, and this is the image that is found from the data set. So both of these images are of the same person but with different expression. So Now let me demonstrate you my program. Firstly, I would like to show you the images for which I'm testing whether they exist in the database or not. So these are the 5 images, and I'm testing for them if they exist in the database or not. And my code also give me an accuracy percentage. Accuracy. So here, this is a readme file which I've made for the easy access of these commands. It's taking a little time, so while it's taking time, let me show you my data set. So this is my data set, and all the images are within these folders. Each folder has a image of the same person with different expressions. So I think so it's done, and as we can see, it gave me an accuracy result of 92.5%. So that means my code is 92.5% correct for these 5 images. Now, so first let's see the input image. First input image was this, for which I'm checking if it exists in the database, and the result for this image is, look, as we can see, all 5 images are of the same person, and it is same as the one which we gave as input. So now looking at the second one, first let's see the second image. It is this one. Well, these two images belong to that same as the input image, but these three are are of a different person. They might be similar as far as features are concerned, but these both are different people. So that's why does not give me an exact result, but an accurate result. And this accuracy of 92.5% is very high. So similarly is for third, fourth, and fifth image. Now going back to my presentation. Yeah, I would like to conclude by saying that I implemented an efficient face recognition system using Eigenface method in Python. It worked efficiently on 5 different test images as I showed, and gave me highly accurate results, and the accuracy being 92.5%. As I discussed earlier, it has wide applications in surveillance, security system, and human computer interaction. And the future scope of my project is that if the low dimension eigenvectors are chosen more efficiently, then it would give me more accurate results. That's all. Thank you.